So I welcome you all. In my today's session, I am going to write C program for generation of square wave. Before I start with program, let us discuss about the square wave. What is a square wave? Square wave has two states, T off time period and T on time period. Using timer, I will generate T off time period, T on time period. And using port bit I will change this status. So port pin will generate logic 0 for T off time period, logic 1 for T on time period. Total time period is T off plus T on and frequency is inverse upon T total. So I assume I am going to generate a square wave having frequency of 1 kilohertz. So for 1 kilohertz, what is the time period? So time is inversely proportional to frequency. So time period of output frequency is 1 upon f. So it is 1 millisecond. So total time period is 1 millisecond. So T on plus T off is 1 millisecond. Now we know duty cycle of square wave is 50%. So formula is percentage of duty cycle is T on upon T total into 100. So what is the duty cycle? 50%. So 50%, 50 divided by 100 becomes 0.5. So the formula becomes 0.5 equals to T on upon T total. Therefore T on is equals to 0.5 times of T total. So T on is equals to 0.5 into 1 millisecond. It gives you 0.5 milliseconds. So using timer, I will generate T on time period of 0.5 milliseconds. Now T off is T total minus T on. So 1 millisecond minus 0.5 millisecond is again 0.5 milliseconds. So using timer, I will generate T on and T off time period of 0.5 milliseconds. So my delay required is 0.5 milliseconds. Now we know that when I'm using timer to generate time delays, it is driven by oscillator. So I assume oscillator frequency as 11.0592 megahertz. This frequency is divided by 12. So 11.0592 megahertz divided by 12, it becomes 921.6 kilohertz. And time period of this is 1 upon f. So 1 upon 921.6 kilohertz gives you 1.085 microseconds. So timer receives clock after every 1.085 microseconds. So how many clocks are required to generate time period of 0.5 milliseconds? So number of clocks required is equals to zero point 0.5 milliseconds upon 1.085 microsecond. This gives me 460.8. So I round it off, it becomes 461 clocks. This is a 16-bit count. So I'm going to use my timer in mode 1, which is 16-bit mode. In 16-bit mode, maximum count value is 65,535. Now we know that our timers are up timer, that is why we have to subtract the required count from the maximum value. And we add 1 because we want to make timer to overflow. So to cause timer to overflow, additional clock is required. So this additional is incorporated within the count itself so that there is no extra clock pulses. So instead of subtracting from 65,535, I am subtracting from 536, 65,536, so that this extra clock which causes the timer to overflow is included within the count. So the decimal value comes out to 65,075 and in hexadecimal it is FE33. So TH value is FE, TL value is 33. So we have determined the count value. Now let us start with the C program. In my C program, I have used delay here. Why I have used delay? The reason is, before I go to the reason, I am generating a square wave on port pin. So I have defined wave as a port bit. So I have defined wave as a port bit. So wherever in my program I have written wave, I am accessing bit number 1 of port 0. So this is off time and this is on time. Now this is the timer routine. Initialize timer, start timer, wait for timer to overflow. And when timer will overflow, loop will be terminated, stop timer, clear flag. Now if I don't use delay function, these statements will be repeated twice. After off time, after on time, these statements will be written twice. So this will increase the program size. This is inefficient program writing. So if I use function, I don't have to repeat these statements. I have to only call function. So I have only called function. I have only transferred the execution to the function and the function generates the time delay. This is not the two places if delay is required at n number of places. So instead of writing these timer routine at n number of places, I will simply call the function at n number of places. So this is efficient programming. That is why delay function is used. So when we use function, we have to first declare a function. So this is declaration of function. This void means this function is not going to accept any argument. I'm going to explain one session in which I'm going to pass arguments. So in that session we will cover how to pass argument. So I have written void here because I am not going to pass any argument here. And this void means this function is not going to return any value. So this is called declaration, this is called calling of function, and this is called definition of function. Definition must match with the declaration. And this is here, and in this function I have written the delay routine. Now I have used one infinite while loop here because I am going to generate continuous square wave. So this is an infinite loop. We will keep on generating off time, on time, off time, off time. So this is an infinite while loop. Tmod timer is configured only once. That is why it is not included within the loop because timer is configured only once. Tmod is initialized with 1. Upper nibble is 0 because I am not using timer 1. Lower nibble is 1 because the 4 bits are gate bit is 0 because I am not controlling timer through external signal. I am using timer as time delay generator, so next bit is 0. I am using it in mode 1, so it is 0 1. So 0 0 0 1 is 1, that is why lower nibble is 1. So let us execute this program. So from the peripheral, open port 0 and timer 0. Now I execute tmod statement. So timer is configured in mode 1. It is used as time delay generator. Okay. Now my off time starts. So I reset the watch now. I call delay. I initialize count register TL. I initialize count register TH. Now here I want to mention one point that timer is not running. Timer is in stop condition now. but already some time has passed. Okay, so calling of delay, initialization of TL and TH. So these statements have executed and these statements have taken some clock pulses. And these clock pulses have inserted extra time. This is called software overhead. It is 6.51 microsecond approximately. Calling of function takes 2 clocks. Execution of this takes 2 clocks. Execution of this takes 2 clocks. So 6 clocks have added to my T of time period. Now timer starts. Now timer will count 461 plus these 6 extra clocks which is included due to software overhead. Now when I execute this while loop, it takes 2 clocks. So you can see here TL which is 34 will become 36, 38. Now when I execute it once, count increases by 2. So to count 461 clocks, I have to execute it 232 times approximately. So instead of executing so many times, now change the execution from single stepping to free running. So I put a breakpoint here and now I change the execution mode from single stepping to free running. Now you can see here when timer overflow flag is set, condition becomes false, loop is terminated, program goes to next line, and here is a breakpoint which stops the execution. The delay is zero point 0.5 approximately, zero point 0.5 millisecond approximately. This is extra time due to software overhead. Now again software overhead comes into picture. I am executing these statements, but the timer has already counted 461 clock pulses. So again extra clocks are added to my T of time period. 1, 2, and this return takes 2. Okay, so total time period is zero point 0.5 milliseconds, but extra time is there 13.24 microseconds. So approximately 10 clocks are added. Approximately 10 clocks are added. So these 10 clocks can be subtracted from the count value to minimize the effect of software overhead. Instead of counting 461, I will count only 451 so that these 10 clocks which will be added due to software overhead makes it 461 and my delay remains the zero point 0.5 milliseconds only. So this is how we can eliminate the software overhead. Subtract the overhead clocks from the count value. Now T on starts. Now total time period is 1.02973 milliseconds. So 29.73 microsecond extra time, which is software overhead, which can be eliminated if I count 451 instead of 461 clock pulses. So that was all about the generation of square wave using 8051 microcontroller. So I hope you understand this program. If you have any doubt, you can ask in the comment box. And if you like the if you like the lecture, so do press the like button and share with your friends also. And do subscribe my channel so that when I load my next lecture, you will be intimated. Thank you. Thank you.